Okay, this is a snapshot of the binomial distribution. Once again, it is assumed you are familiar with this topic. Also, it is assumed you're familiar with the following. What you mean by a probability distribution? What do you mean by a discrete distribution? And from counting, the meaning of choosing a combination of k objects selected from a total of n objects. If not, you need to go back and review these ideas and then get back to the worksheet. Now, a random variable x is said to have a binomial distribution if the following conditions are met. There are two possible outcomes. We typically label them success or failure. Good or bad, yes or no, pass or fail, like or don't like, etc. Then the experiment is being performed a multiple number of times, and we let n represent that number of times the experiment is being performed. So I ask a person a question, just say yes or no. There are two possible outcomes, but when I do this with a group of people, say 100 people, then what we have, if we count how many successes we have, or failures we have, whichever way you want to go, okay? The random variable that is counting the number of successes is referred to or is said to have a binomial distribution. So, two possible outcomes, experiments being performed multiple number of times, and we're counting the number of successes. But again, counting success is really no different than counting failure. All right, so once we identify something as binomial, the first thing we have to make sure of is what we're actually counting. Because what we're counting is associated with the following. So once we decide what we're going to count, yes or no, true or false, success or failure, we next need to know the total number of possible things we can count up to. That is, how many times has the experiment been performed. Second, we want to know the probability of what we're counting. That is the probability of success. Look at X, whatever you're counting, P is associated with the probability of that outcome. Q is the probability of failure. Since there's only two things that can occur, Q is related to P by 1 minus P. Now, here are some other facts in regards to a binomial distribution. So if X is binomially distributed, its mean is n times P. Its standard deviation is the square root of npq. And we have a formula for the probability that X is going to equal to a particular number. The probability that we get so many successes in n trials is given by this formula right here. Okay, so we'll simply remind you, C of n pick k is a combination of k items selected from n items, and there's no order. That's from counting. So I'm going to go through a couple of problems here just to determine if it is a binomial distribution or not. We're tossing a coin. We're tossing it 15 times, and we're recording the number of tails. That is, X is counting the number of tails. Well, there's two things that can happen, tails or heads. We're counting how many tails we're getting. Okay? So therefore, X has a binomial distribution. Assuming that it's a fair coin, we know that n here is equal to 15. The probability of what we're counting, which is tails, is 1/2. We're assuming it's a fair coin. We were not told otherwise. So Q here is also 1/2 because it's 1 minus P. Okay, so those are the key properties. How many times is the experiment being performed? Well, we already decided what we're counting. The probability of what we're counting. The probability of the opposite. So A is a binomial distribution. B, a box contains 500 light bulbs and the number of defects is determined. Assume the probability of a defective light bulb is 0.10. Well, if I let x equal to the number of defects I'm counting one of two things. It's either defective or not defective. The number of possible things that can count up to is 500. The probability of what I'm counting is 0.1. So the probability of not getting a defect, which is the opposite, is 0.9. C. Again, you should be stopping the video. You should be working problems. If you're just trying to mimic me, it's not going to work, especially on the final exam. 75 students are taking an entrance exam for which you either pass or fail. In the past, 5 out of 9 students would pass the exam. Let x be the number of students who fail. So here we're letting x be the number of students fail. You either pass or fail, one of two outcomes. We're counting how many students fail out of 75. So yes, this is binomial. So again, we've already defined what x is counting. The total number of possibilities is 75. Now where are we getting the probability of success or failing? Right here. 5 out of 9 students would pass. Now we're counting how many who fail. Be careful. So if we're counting how many who failed, the probability of failure is 4 out of 9. And Q is 5 out of 9. Sorry, I left off my equal sign. All right? So be careful. N is the total number of things you can count up to. P is the probability of what you're counting. And Q is the probability of what you're not counting, the opposite. So again, C is binomial. Number D, or letter D. 300 students were surveyed and asked what their favorite brand of drink was. And X is the brand a student drinks. Well, X has multiple possible outcomes, right? Not just two. There are a lot of drinks out there. Last time I looked, there were hundreds of types of drinks you can drink, right? So this is not binomial. Now look at it slightly reworded. 300 students were surveyed and asked what their favorite brand of drink was. 70 students' favorite was water. Suppose I select 60 students at random and count how many drink water. Well, if we let x equal the number that drink water, then x now is binomial. Why? Either you drink water or you don't drink water. Two possible outcomes. Even though the underlying survey had multiple outcomes, I decided I was going to count those that drink water. Whether either you drink water or you don't drink water, two outcomes. The total number of possible people that drink water in my survey is not 300 but 60 because that's what I'm choosing from, right? The probability they drink water comes from the 300 because we said 70 out of 300, that's a 300, drink water. So the probability they don't drink water is 230 out of 300. All right, so now we're going to actually start working some probability type questions here, okay? I'm going to stop this video and start another video because I don't like my videos going too long in case something goes wrong. So we're going to have another video button located right here for the second video.